Hello, my name is Mohammed Zubir Bahad, and in this video we will discuss example number 5, hydrostatic on a plane surface. The question is, a vertical submerged gate of 0.5 meter wide and 3 meter high is hinged at the top and held closed by water as shown. What horizontal force applied at the bottom of the gate is required to open the gate? Okay, so first of all, you need to understand the story behind it. Okay, so since this gate having an hinge at the top, okay, so when you have a hinge at the top, all right, so let's say we call that hinge as the point E. Okay, so point E here is the hinge. All right, so when you have a hinge, it means that the gate can be rotated at that hinge. All right, because this is a hinge, and then if you putting a force beside the gate, so the gate will start to rotate. Okay, so hinge is a place where a body can have an exit of rotation. Okay, and this rotation can only happen if, all right, we have a force, all right, and the force times the distance, so we create what we call a moment. Okay, it will create a moment. Okay, so now what happen is we don't have what happen if we doesn't have this force of P at the bottom there. Okay, so when we don't have that P, we know that every time when we have a fluid and then they have a surface, okay, and then there must be a force, all right, there must be a force acting on the surface, and it act 90 degree, all right, act 90 degree in this case, for example, in this case, all right, it will create they will have a force somewhere there. Okay, and this force, all right, will create a moment which will open the gate. So if you want to make sure the gate will stay on as is being shown in the figure there, all right, so we need an extra force, or we call it the external force, all right, to hold the gate in place. Okay, so our objective today is to determine what is the value of this P, all right, in order for the gate to stay as it is. Okay, so number one, you understand the story. So in other words, we can say that the sum moment, all right, the sum moment of force, all right, sum moment, all right, the sum moment at a point E, all right, the point of rotation in this case, all right, so sum moment at E must equal to 0. Okay, and we need the moment equation, all right, before you can create a moment equation, all right, and then you know the story is related to hydrostatic force. So when it is related to hydrostatic force, you need to draw a free body diagram, a simple free body diagram, okay, and start with the point of CG. All right, so let's assume this is the CG, all right, point of CG, and the distance from the CG, all right, to a free surface here, all right, you still call it as the H bar. Okay, and let's say the hydrostatic force act at a point of CP, center of pressure, which always deeper compared to the CG. All right, so in other words, the HCP, all right, must be longer compared to the H bar. So you have your HCP here. All right, HCP. Okay. All right, and then from there you can create, okay, create a moment equation. But since you are taking a moment at a point E, so we need a distance from CP to the point E, and why don't we call it as a point? Call it as a point E. Okay, so you write the general moment equation at a point E as the P times 3 is equal to the hydrostatic force times the distance to a point E, which is an A. Okay, so in other words, we can solve P if we know the force and know the distance of A. Alright, so why don't we start with the force? Okay, so force, the hydrostatic force is equal to rho G H bar times A. Okay, and the fluid is water, so it is 9810. And then the H bar, whenever you try to determine H bar, look back at your free body diagram there. The H bar is from point of CG to the free surface. Okay, you know that from the CG to E, the distance is half of the gate, which is 3, all right, divided by 2. All right, as you go up to point E, and then, but you need to go to the free surface, you add another 1 meter. All right, 1 meter, and then the area of the submerged gate in this case is equal to 3 times 0.5. Okay, and then from there we know that the F is equal to 36.8 kilonewton. Okay, so you're done with the force. All right, so we're done with the force. Okay, and now it's time for us to determine the value of an A. Okay, so the A, all right, from the figure there, from A, it is clear A actually is equal to your HCP minus 1. All right, so the HCP, all right, the HCP is equal to H bar plus the ICC sine square theta divided by H bar A. Alright, and then you know this is a rectangular. Alright, so your H bar is equal to BH cube, and the sine is sine 90, which is equal to 1 divided by H bar divided by 12, don't forget the 12, and then time the H bar and time the area of the gate, the submerged area, which is the base times the height. All right, so this base and that base at the top is the same base, and the height is the same, so cancel it. And lastly, you have your HCP is equal to H bar plus the H square divided by 12 H bar. Okay, or if we put the value there, you will have the HCP is equal to 2.5 and plus your H in this case. And once again, how do you want to determine the H? Remember the OX is at the top here, and then you transfer it to the center of this body. Of course, the line of OX or crossing the 3 meters, so the H actually is a 3. All right, so 3 square divided by 12. All right, divided by 12 and time 2.5, and your HCP is equal to 2.8. All right, 2.8 meter. All right, but we are not looking for HCP, we are looking for A. Your A is equal to 2.8 minus 1. All right, 2.8 minus 1, so you have 1.8 meters. Okay, so take this A, put back into our moment equation, and finally you have your P as 22.1 kilonewton. Okay, so that's how we determine the external forces. All right, these external forces can only applicable in our hydrostatic problem when there is hinge, all right, involved in the operation or involved in our calculation. Okay, so that's how you solve a problem when you have a hinge or you have the external force. Okay, so once again, all right, the free body diagram is the most important factor in determining whether you will get the correct answer or not. Okay.